Hello Rama. In today's lecture, we are going to learn how to create a TPMS lattice based cylindrical volume lattice. So first, we can give the name of the file as TPMS cylindrical volume lattice. Okay, and let's give the add the description as the generation of TPMS cylindrical volume lattice, and our section name is TPMS cylindrical lattices. Okay, so to design TPMS cylindrical volume lattice, so we need to select cylindrical volume lattice as a one geometric parameter, and the second is TPMS unit cell as a second geometric parameter. So let's select them in lattice tab. In lattice tab, we can go to the lattice tab again, and there we can find the cylindrical volume lattice. Let's select that. So after selecting this, what do we observe? It has some input geometrical parameters such as volume, unit cell, and respective cell radius, cell height, and number of arc counts, and frame also. If you want, if somebody wants to give, they can give. But nTopology is suggesting that it is optional. It is up to you as per requirement. You can select that. And the most important parameter, that is unit cell parameter. So let's go one by one. So first select the volume. So in today's lecture, we are going to create the cylindrical volume lattice. We have the entire volume as a cylinder, but we are going to create a volume. It is up to you. It can be cube, it can be cylinder, it can be sphere, it can be cone, it can be anything. It's any complex geometry, but it is within the cylindrical volume system. But the volume system is remain cylindrical, but we are going to crop. We are going to take a part from that. We are going to take the some volume of the part within the cylindrical volume system. Okay, so for that, today in our lecture, we are going to select cylinder only. So let's select the cylinder we have selected, and this is our cylinder. Okay, now what do we observe? It has point 1 and a point 2. It means that our initial point is this. Our initial point is this point represent the 0 0 0 along a UVW, and this point represent the height up to the 10 mm height. If somebody wants to change it, they can freely change it. And the radius of the cylinder is the radius of cylinder from here to here is like a 5 mm. So it is also doable to change it as per the one's requirement. Now this portion is completed. Let's select the unit cell. Okay, so for this we can go to the unit cell tab, and in today's our lecture we're going to select the TPMS unit cell with offsets. And yeah, after selecting this, what do we observe? We observe that it has two parameters. We observe that it has two parameters. One is a unit cell, and another one is unit orientation. So let's select the unit cell type. Yeah, here in topology, by default we have total 6 TPMS lattices, so we can use any one of them. So in our today's lecture, we are going to first select the gyroid. Later on, we can select the other as well. It's based on one's requirement. So let's select the gyroid. Yeah, this is our unit cell, gyroid TPMS cell with the offset. Now let's place this within the unit cell tab and minimize this. Yeah, keep the cell radius as it is, and cell height as it is, and cell arc count as it is. We can vary it later as well. Now the most important parameter here, it is a mid surface offset. So how much offset we should give. So let's give the offset as a 0.25, and let's see what is going to happen. Wait for some time. So now it is going to generate the lattice. Yeah, we have generated this. So this is our gyroid TPMS unit cell with the offset. So suppose what do we observe here? It's like it's too much bulky, isn't it? So the its relative density is relatively high as compared to as compared to porous nature. So yeah, we need we don't want more relative density. We want it as a higher porosity. For that, we can change the thickness like a 0.1 mid surface offset. Then we can see it's going. Yeah, so here we can observe one thing by selecting the. So now we can observe what are the parameter we have given exactly. Okay, so here if you see this total arc count, we have given 8. So how many arc count? 1 2 3 4 5 6 7 8. So total arc count is 8. And if you see the radius, cell radius, we are not able to identify here, but it has a cell radius due to its a cylindrical, like it's a surface nature. So it is a total how much radius we have given? 5 mm na? So if somebody wants to change it, I suppose I want to change it as a 2. Let's see what is going to happen. So see, so now it got changed now. So our unit cell size is increased, isn't it? So this is how one can tune this geometrical parameter. Even if you see the height of the sample, it has so many layers. If somebody wants less layer, if somebody wants less layer, so I can reduce it to 2. Then let's see what is going to happen. Yeah, this is how one can generate it. So I hope we have learned it and how to generate and all. One can tune the height of the parameter. I suppose somebody wants like a 15 mm height. Then see what is going to happen. See, so it means within the cylindrical volume, so one can create the cylindrical within the cylindrical volume lattice. One can create the cylindrical volume or like a cubic volume or a spherical volume, say a conical volume. It's up to you. So in our today's lecture, I just demonstrated like a cylinder volume only, isn't it? So this is how one can tune the height of the sample, radius of the sample, and again within the unit cell, radius of the cell, unit cell, and height of the unit cell, and arc counts, number of arc counts do we want to use, and the mid surface thickness. So this is how one can tune it. And one more thing I can say that one can also tune the unit cell type. Suppose I have selected a squads one. So let's see. Yeah, this is our squad unit cell. Okay. So let me reduce the height of the sample. Yeah, these are our squads unit cell. So one can able to see this. Even suppose somebody wants to further reduce its thickness, and then we can able to see the its porous nature high. Yeah, see. So this is how one can tune the mid surface parameter. Even if you go to the display side, and I hope if somebody wants to select this, mid surface offset. Uh, okay, there is no chain team. So I hope this is how one can vary. Let's see the diamond unit cell. See how beautiful it is. So, okay, I hope you have learned. So, let's recap what we have learned. In today's our lecture, we have created the TPMS based cylindrical volume lattice. For that, we have selected the cylindrical volume lattice from the lattice tab, and then we have selected the we have selected some geometrical parameter such as volume as a cylinder and unit cell from here, that is TPMS unit cell with the offset. And later on, we have tuned the its respective geometrical parameters, and at the end, we also tuned the unit cell parameter like thickness. So, this is all about our unit cell. I hope you enjoyed this. So you have learned something else, something. So let's save this. Okay, that's it for today. Thank you. I hope you understood this. So thank you.